So today we are moving into chapter 9, solving quadratic equations by graphing. We're going to learn other ways to solve them, which are much easier and more helpful than graphing, but I do have to teach you this concept as well. Because Google isn't very graph friendly, what we're going to do is, for your assignment today, you're just going to take these notes so I can see all the graphing that you're practicing, and you're going to upload them to Google Classroom. So that would be your only assignment today. There's no written assignment. Okay? So back in chapter 7, when we factored, just as kind of a review here, we took x and x. We wanted two numbers that multiply to give you negative 12. So that's a 4 and a 3. And then we wanted a positive 1, so plus 4 minus 3. We then set that equal to 0 and solve them. So you get negative 4 and x equals 3. Today, we're going to graph to do that, to find that answer. So basically, if you were to graph this parabola, it wouldn't look exactly like this, but something like this. It would be opening up, and it would cross the x at negative 4 and positive 3. It would cross the x there because y is 0. So you're not going up and down at all on the y-axis. So it's whatever your x-intercepts are. Another name for that is your roots. Another name is your zeros, okay? So there are 3 cases. It'll cross, just like that example up there, it'll cross the the x-axis twice. So that means you have 2 roots. So an example could be like that. I'm not going to redraw that one. Or you can also have something that's opening down that crosses twice. The second option is when you have only 1 root, which just means that the vertex is on the x-axis. So if you had something like this, and the vertex is right here, that's your vertex, you're only going to have 1 root. It's also called a double root, which seems weird, but this happens when you have this, x squared, something like this. If we factored this is a perfect square trinomial. So when you factor it, you'll get this, right? So this equals negative 5, and so does this. So we would always just write our answer as negative 5. Same thing here. It only crosses once. Even though it's twice, you only use it once. And then the last type is no real roots, when it wouldn't cross your x-axis. So this may happen when you had prime. Remember when we tried to factor things and we couldn't? We said was prime. So if it's up here and it opens up, it'll never cross the x-axis. And same thing here if it's underneath and it opens down. So that's no real roots. Here's the problem with graphing and with factoring. This is the limitations. You can also have rational roots, which means that maybe here's 1, here's 2. What if it goes right in between? So unfortunately, we're going to have a fraction root. So that's hard to see when you graph, and you also can't find it if you factor. So as we move into chapter 9, we'll find ways to solve those more efficiently. Okay, so pause if you need to catch up. I'm going to go to the back. All right, so I don't know if I ever said this before, but you're allowed to cheat with these. The reason is it's just too much. You can be graphing forever, and it just takes so much time. So here's what I suggest. Try to factor it first, because that gives you the answer. We'll have to round out the parabola, so you still have to know what you're doing, but we're just going to get a jump start. So you want 2 numbers that multiply to give you negative 10, and combining a negative 3. So you would do negative 5 plus 2, right? Set that equal to 0. You'll get 5 and negative 2. Remember, that means that it crosses there and there, okay? This is a hint to always find the vertex, the negative b over 2a. The problem is, this I know ahead of time, this is going to be fractions, but we still have to find the vertex to see kind of how to round this out. So remember, using this, negative b would be positive 3 over 2 times 1 is 2. So that's my x. Now I'm just going to tell you what the y is because we'll be here forever. So the y is negative 49 over 4, right? So you have 49 over 4 is about, what, a little over 12, right? 12 and a quarter. So you want to go 1.5. So it's basically off, okay? We could maybe use other points here to try to round it out a little bit, but I don't really want to. So we're gonna just do this. And there we go. We solve by graphing. Look at that. It crosses at -2 and +5. Okay. For this one, let's cheat again and get it equal to 0. Okay, just looking at that, I know it's a perfect square trinomial. If you don't see that, we'll factor. Two numbers that multiply to give you 9, combine to give you -6. When you set these equal to 0, you get x is 3. That means 1, 2, 3. That's the vertex. So your vertex is 3, 0. So we really do need to round this out. So remember when we took something that's kind of close, let's put in x equals 0. If you put a 0 in here, you'd get 0 minus 0 plus 9. So you get 9. I'm also going to draw this axis of symmetry to help us. Okay, so 0, 9, we're 1, 2, 3 to the left, 1, 2, 3 to the right, and you can just round it out. Now, if we were in school and all, we would be doing more points. We can do like x is 1, x is 4, and kind of be more accurate, but it's all good. All right. So let's try number 3. Let's factor that first. So factors of 3 are just 3 and 1. But they both have to be positive or both have to be negative because the 3 is positive. If I make them both positive, it's not going to get a 2. If I make them both negative, it's not going to get a 2. So if you can't factor it, it's one of two things. It's either going to be no roots because it's not going to cross it, or it's going to cross at a decimal or fraction. So unfortunately, we can't cheat with this. So we're going to say x is negative b over 2a. We're going to find that vertex. So 2 would be negative 2 over 2 times 1. Negative 2 over 2 is negative 1. Plug that negative 1 back in. I'm just going to tell you the answer so we save time. 2. So negative 1, 2. So this is where you want to ask yourself, is this opening up or down? This is positive. It's going to open up. Will it ever cross this? Nope. So it'd be no real roots. But you would still need to round that out a little bit. So I'm at negative 1. Let me just let x equal maybe 2 or 2. And plug that in. 2 squared plus 2 times 2 plus 3. So you get 4 plus 4 plus 3, so you get 11. Man, I can't graph. I'm at negative 1, 3. I did this last time too, sorry. All right, so you have 2. Okay, this is my axis of symmetry. So I'm 1, 2, 3 to the left, 1, 2, 3 to the right. And then just round it out. But your answer would be no real roots, okay? Your answer up here would be 5 and negative 2. Your answer over here would be 3. So we did all 3. So this is, let's see what happens here. You can try to factor this. It won't factor. So again, it's either no real roots or they are integers. So let's find the vertex. Negative b over 2a. So it'd be 4 over 2 times 1. So you get x is 2. Save time. I'm just going to tell you it's 2, negative 2. So here's your vertex. It's opening up because this is positive. So it is going to cross. So this is where you have to just start plugging in stuff. I'm going to start easy and plug in a 0. If you plug in a 0, you get 2. So we can do this, right? So 0, 2. So just to be more accurate, I'm gonna let x equal 1 to see where here this happens. So you put 1 in, you get 1 minus 4 times 1 plus 2. So you get -1. So then just use symmetry. So when you connect this, you have to do it carefully. You could see right there and right there. It connects between 0 and 1 and 3 and 4. And that would be your answer. It's annoying, right? You do all that work and you don't even get a real answer here, okay? So there are all your options that could happen when you graph. I don't like this at all because I feel like you do all this work and it doesn't always work and it takes so long to do. So the good news is we're gonna learn easier ways to do this. The bad news is you have to know how to do this anyway. So again, this is your assignment. Make sure you have all the graphs done. Make sure you have all your work out. And you need to upload that to me by tonight. Just upload it to Google Docs, okay? All right, guys, hopefully you're doing well. I miss seeing you all. Have a good one.